Parity is one of my favorite themes from mathematical reasoning, and in this short masterclass, I'm going to help you understand this idea in the context of how it's used to solve very interesting number puzzles. So, first, let me show you what we will solve at the end of this video, the capstone problem of this masterclass. It says the numbers from 1 to 29 are written over a board. So, you can see this board here, the numbers from 1 to 29 are written on this board, and then two numbers are randomly chosen from this set. Both are then erased and their positive difference is written instead. So, for example, if you choose the numbers 2 and 9, you replace them with their positive difference, which is 7. So, you take out 2 and 9, you rub these two numbers off the board and you write 7 instead on the board. And this is done repeatedly. This is done repeatedly till there is only one number left on the board. So, this step is done repeatedly. Take two numbers, replace them with the positive difference. So, at every step, the number of numbers on the board decreases by 1, and obviously ultimately there should be just one number left on the board. And the question says, can that number be 0? And that is the capstone problem of this masterclass that we will solve at the end of this video. And you might find this to be tough, but we will slowly, steadily, systematically build towards it. And at the end of the video, you'll actually find it very, very easy to solve. But if you want, you can pause the video for now, give it a shot on your own before you go forward. Okay, let's get started with what is parity. So, parity is simply the property of a number of whether that number is even or odd. So, for example, if you think of the numbers 2, 6, 14, 76 and so on, all the even numbers, essentially that's parity, that's even parity. So, these numbers are numbers of even parity, and I mean they are essentially divisible by 2, and then you have numbers of odd parity. So, 3, 7, 19, 87, so all the odd numbers, these are numbers of odd parity, they are not divisible by 2. So, parity is simply the property of a number of whether that number is even or odd, very straightforward. But what I really want to focus on and get you to visualize is this visual model of parity. So, look at this model here, which is the parity model for the number 6. You have 3 circles here and 3 circles here. So, it is a balanced model, 3 and 3 together make 6, and for every even number, this model, the parity model, will be balanced. But for odd numbers like 5 in this case, the model is unbalanced because you have one additional circle that can't really be balanced, and that's simply because that number is odd. So, every even number will have a balanced model and every odd number will have an unbalanced model of this kind. Now, how does that help us? Well, this thing helps us think about combinations of numbers with different parities. So, let's think of this problem and how we would apply the idea of the model we just saw to solving this problem. So, this question says find 3 odd numbers which sum to 30. So, you have to find 3 odd numbers which sum to 30. So, for example, if you take 13 and 17, their sum is 30 indeed, but they are only 2 odd numbers. So, this solution does not really work. And similarly, if you take the numbers 7, 9 and 14, their sum is 30, but you actually have an even number in this set. So, this set also does not work. So, your problem is to find 3 odd numbers which sum to 30, and I will now help you understand how to solve this problem by using the visual models of parity that we just saw. So, what we will do is we will look at parity of sums of two numbers. So, if we take an even number and an even number, so if we take two even numbers and put them together, what will be the parity of the sum? So, in this case, for example, this is the model for 4 and this is the model for 6, and you can instantly see that putting them together will give you yet another balanced model, and therefore, the sum that you will get is even. So, even plus even gives you even. You can, of course, you do not need the visual models to deduce that, but the visual models actually help you grasp the whole idea instantly. Similarly, if you have an even and an odd number, so you are combining them, you have an even balanced model, you have an odd unbalanced model, you combine them, what should you get? You should get an odd number because the combination will be unbalanced. And finally, if you have an odd number and an odd number, what you should get is an unbalanced model combining with another unbalanced model, but they fit together to become balanced, and therefore an odd number and an odd number should sum to an even number. So that's the basic idea here. So put two even numbers together, you get an even number. Put two numbers of opposite parity together, one even, one odd, you will get an odd number, and put two odd numbers together, you will get an even number. So very straightforward. And if we extend that idea and now look at parity of sums of three numbers. So if you have three even numbers being put together, you can see that the combination will stay balanced. So the sum of three even numbers will also be an even number. But you have two even and one odd, then the combination will be unbalanced. So two even and one odd will sum to an odd number. And if you have one even and two odd, then you can see that the model will become balanced. So you will get an even number as the outcome. And finally, if you put three odd numbers together, what should you get? The first two odd numbers will balance, and therefore you'll get an even number, but then you stack on the third odd number and the sum will be unbalanced, and therefore the sum of three odd numbers will be odd. So now coming back to our question, find three odd numbers which sum to 30. The idea, the solution is very straightforward. If we put three odd numbers together, the sum will be unbalanced, or in other words, the sum will be odd. But 30 is an even number. So there is no combination of three odd numbers that will sum to 30, and therefore solving this problem is impossible. You can't find three odd numbers which sum to 30. Now if you extend this to this next question, find five odd numbers which sum to 100. That's question number 2. The idea is very straightforward and similar once again. The question you have to ask yourself when you see a question like this, when you see a problem like this is, what must be the parity of the sum? If you have five odd numbers, you put them together, what must be the parity of the sum? And you can see from this visual model here that two odd numbers and then another two odd numbers will combine to give us balanced sums, but then the fifth odd number will make it unbalanced, and therefore the sum of the five odd numbers will be an odd number. But what we want is a sum of 100 which is even. So yet again this is not possible. You can't find five odd numbers which sum to 100. In fact, any such question which says find so many odd numbers that sum to a number, if the number of numbers being asked of you, so in this case 5, in the previous case 3, if the number of numbers is odd, then putting an odd number of odd numbers together will give you an odd number, and the sum can never be an even number therefore. So that's this question. Now here's a challenge for you, and I want you to solve this challenge and share your answer in the comments. The first part of this is, can you find 100 odd numbers that sum to 999? So that's the first challenge. And the second one is, can you find 50 odd numbers that sum to 100? So think about the ideas we just discussed, solve these challenges, and then share your answer in the comments. Now let's keep moving. Now we will extend the idea of parity from natural numbers to more general integers. And the question I have for you is, what do you think is the parity of negative integers like -3, -8, and for that matter, what is the parity of 0? Just imagine the integers on a number line, and let's say pick any even number. So 4 is an even number, so I'll write E here. Now if I go one step before 3, that's odd, one step before is even, one step before is odd, and therefore extending that idea, 0 should simply be an even number, and of course 0 is an even number, it is divisible by 2, so 0 is even, and similarly -1 should be odd, -2 should be even, and so on. So the idea of parity can be very easily extended to negative integers and 0 as well. So -3 will have odd parity, -8 will have even parity, and 0 is even. 0 has even parity. Okay, and then what about combinations of integers? What is the parity of combinations of integers? We spoke about parity of sums of natural numbers, but let's extend that idea to think about combinations of integers. So for example, if you put two even integers together like -4 and 2, what should this give you? So -4 is over here on the number line, and +2 means you're jumping 2 steps, right? So you're landing up at -2, which is even. So the sum of two even integers or the combination of two even integers should be an even integer. What about even and odd? So you're adding 2 and minus 5. So if you are at 2, which is this point here, and you add minus 5, which means you go 5 steps backward over here. So you're clearly landing at an odd integer. So even plus odd should be an odd integer, and similarly odd plus odd should be what? It should be even. Let's take an example. Minus 1 and minus 3, if you add them, so you start at minus 1, add minus 3, which should give you minus 4, and therefore odd plus odd is also even. And all of this is very straightforward, but it's still important to cover this more general combination of integers systematically. That's what we're doing here. So you can also think of parity of combinations of integers, therefore two integers or more integers, just like we can do with natural numbers. So here's the next question. The numbers 1 to 10 are written on a board as shown below. Can you put plus and minus signs between them so that the resulting expression equals 0? And this is a very interesting question. So if you want, you can actually pause the video here and do give it a shot on your own before you see how I solve it. So the question says put plus and minus signs between these 10 numbers so that the resulting expression equals 0. So let me just put some random combination of signs. So let's say plus here, let's say plus here, and minus here, plus here, minus here, minus here, minus here. So let's say I've placed my plus and minus signs in this way. So what is the value of this expression? So 1 plus 2 plus 3 plus 4 is 10, minus 5 is 5, minus 6 is minus 1, plus 7 is 6, and then 6 minus 8 is minus 2, and then minus 11, and then minus 21. So this is clearly not equal to 0. So the question is asking you, can you somehow place plus and minus signs between these numbers so that the value is 0? So how do you solve this? How do you go about figuring out what is the right placement of the signs? So there are three approaches that I will share here. The first approach is to simply look at combinations of odd and even numbers separately. So, and I'm using the word combinations and not sums because some of these numbers in the expression will be positive, some will be negative. For example, if in front of the 5 you have a minus sign, then the sum will have a contribution of minus 5 from this 5, and therefore what we need to think about is combinations of odds and evens in this expression. So let's once again take any random placement of signs. So let's say 1 plus 2 minus 3 plus 4, and then let's say something like this. Okay, so the odd integers in this combination are 1, minus 3, minus 5, 7, and minus 9. So there are 5 odd integers in this combination, and similarly there are 5 even integers. Now the combination of the 5 odd integers, no matter what the placement of the plus or minus signs, the combination of 5 odd integers will be odd because you are combining an odd number of odd integers. So the combination of the 5 odd integers will be odd. The combination of the 5 even integers on the other hand, so 2, 4, 6 and minus 8 and minus 10. So the combination of these 5 integers will be even, and therefore finally if you combine the odd and the even combination coming from all the odds and all the evens, you should get an odd combination as a result, but 0 is even, and therefore there is no placement of plus and minus signs here that can get you the resulting expression to be 0. So the answer is that this is not possible. So that's approach 1. Another approach here is to start with all the plus signs in your expression. So let's do that. So let's place all plus signs in this expression and look at what the value of the resulting expression is. So the sum of these 10 numbers is 55, and you can actually verify it. It's the sum of the first 10 natural numbers. So the sum will actually be the first 10. So because the number of naturals you're adding is 10, so 10 times 11 by 2. The formula for adding the first n natural numbers is n times n plus 1 by 2. So it's 10 into 11 by 2, which is 55. But if you don't know this formula, that's fine. You can directly add the 10 integers, the 10 numbers as well. So the original sum, the starting sum is 55, which is odd. Now, what I want you to think about is what will happen to the parity of the expression if any sign is changed from plus to minus. For example, if this plus sign here is changed to a minus instead, what will happen to the parity of the sum? So, when this was a plus sign, this 5 was contributing plus 5 to the sum, but when this changes to a minus sign, it will contribute a minus 5. So, the sum will change from 55 to 45. The decrease will be 10, double this number. So, if you change this plus sign to a minus sign, the sum will decrease by 10, an even number. So, the starting sum is odd, and then you changed this plus to a minus sign, and therefore there was a decrease of 10, but then the resulting sum will also be odd. 45 is also odd. And then if you do this yet again, so let's say you change this plus to a minus sign. So this 8 will now not contribute plus 8 to the sum, but it will contribute minus 8 to the sum. The sum will drop by 16, and the sum will drop by 16, which is an even number. But because we had an odd sum to begin with and it's dropping by 16, the resulting sum will be odd as well. So at every step you can see that as you keep changing the signs from plus to minus, the resulting sum will still be odd. So no matter how you change the signs from plus to minus, you will still get an odd number, and therefore it can never be 0. So that's approach 2, and I find this to be very elegant and very nice. And then approach 3 is you just try to balance the positives and negatives. So what does that mean? Well, you need a 0 as a result of whatever signs you place here. So think about how you can get 0. So some of these numbers should contribute positively to the sum, and some of these numbers should contribute negatively to the sum. So if you draw like a column of sorts and you say I'll write all my positive numbers here and I'll write all my negative numbers here. So for example, if because I don't have any sign in front of 1, 1 will always show up as positive. So I'll write 1 here, and then let's say if 5 was negative, I would put my 5 over here, and then if 7 was positive, I would put 7 over here. If 9 was negative, I would put it over here, and so on. So you try and balance all the numbers between these two columns, and then you try to figure out an arrangement where the sum on the positive side is the same as the sum on the negative side, because what you want is the final sum to be 0. But now if you think about it, the total sum is 55, which is an odd number. So there is no way you can split 55 in two balanced parts where one of them is positive, one part of the sum is positive, one is negative, and they cancel each other out, and therefore you get 0. That is not possible because the total sum is 55, which is an odd number. So this yet again tells you that solving this is not possible. No placement of plus and minus signs will give you 0. Okay, but what if instead of 1 to 10, we had the numbers 1 to 8? Can we now put plus and minus signs between them so that the resulting expression equals 0? Well, in this case, if you look at the combinations of odds and evens, which was approach 1, there are 4 odd numbers and 4 even numbers. So in theory, yes, you will get a combination that is ultimately even, and therefore it could be 0 if you place your plus and minus signs correctly. Similarly, if you start with all the positive signs, which was all the plus signs, which was approach 2, you can find that the sum here is 36, 8 into 9 by 2. And then at every change from a plus to a minus sign, the resulting sum will still stay even, and therefore you could get it down to 0. So let's really use approach 3 here to solve and find the exact placement of plus and minus signs. So we'll try to balance the positives and negatives, so in a way such that the resulting sum is 0. So I'll write my positives here on the left and the negatives on the right. 1 is always positive, so I'll keep 1 this side. And then what do I need? I need the positives to add up to 18 and the negatives to add up to minus 18, because the total sum is 36. So I need half of that to be positive and half to be negative. So I already have a 1 on the positive column. I need 17 more. So let me just pick 8, 7, and that's 15, and then 2. So that's 17. So I'll put 2, 7, and 8 in this column, and then I'll put everything else on the negative column. So 3, 4, 5, 6, I will put on the negative column. So minus 3, minus 4, minus 5, minus 6. And now you can check that the sum of these integers is 18 and the sum of these integers is minus 18. So the sum is 0, and therefore all I need to do is 1 plus 2 and then minus 3, minus 4, minus 5, minus 6 plus 7 plus 8, and that gives me 0, and this question is solved. So the reason this worked here is that the sum of these 8 naturals is an even number, and that's why it works in this case. Okay, now here's a challenge for you, challenge number 2, and once again what I want you to do is solve this and share your approach and answer in the comments. And here's what the challenge says. A nerdy mathematical insect, which you can see over here, very cool looking insect, is initially standing at the position 0 on the number line, and then it makes a sequence of jumps that are of lengths 1 centimeter, 2 centimeter, 3 centimeter, and so on, and each jump is either towards the left or towards the right. So you can see, for example, that the insect's first jump is 1 centimeter towards the left, then the second jump is 2 centimeters towards the left, and then the third jump is 3 centimeters towards the right, and then the insect makes a total of 49 such jumps. So the question says, can the insect land up at 0 after 49 jumps? So that's the challenge you have to solve, and if you are able to figure it out, or if you want to discuss it, you can share your answer or approach in the comments. Okay, now here's question number 4, kind of extends the parity idea. The product of 14 integers is 1. Can their sum be 0? So the product of 14 integers is 1. So the key to solving this question is in the fact that the product is 1, and the product of a certain number of integers can only be 1 if those integers are either 1 or minus 1, because if you take any other integer, the product will be either absolute value will be larger than 1 or it could be 0, but the only way to get some numbers to multiply to 1, some integers to multiply to 1, is if all of them are either plus 1 or minus 1. So let's take maybe a smaller number instead of 14 to understand how to think about this problem. So if you had 4 integers which had a product of 1, could their sum be 0? Yes. If you take the 4 integers 1, 1, minus 1, minus 1, these are 4 integers whose sum is 0 because you have 2 1s and 2 minus 1s, and their product is equal to 1 because you have an even number of negative 1s. So the product will come out to be 1. But if you had 6 integers, the product of 6 integers, let's say, is 1. In that case, can their sum be 0? So if the sum of 6 1s and minus 1s needs to be 0, then we must have 3 1s and 3 minus 1s. That's the only way the sum will be 0. So if we had 3 1s and 3 minus 1s, then their sum would be 0, but then would their product be equal to 1? Not really, because you have an odd number of minus 1s and their product will be minus 1. So now let's just extend that idea to 14 integers. For 14 integers that are either 1 or minus 1, to have a sum of 0, 7 of them should be 1 and 7 of them should be minus 1. But you have 7, if you have 7 minus 1s, then the product of those 7 minus 1s will be minus 1. So the overall product cannot be equal to 1. And therefore, the answer to this question is, this is not possible. The sum cannot be 0 if the product of 14 integers is 1. Now, here's a challenge for you, one more. Challenge number 3 of this masterclass. The sum of 100 integers is 0. Can their product be minus 1? So yet again, just think about how I solved the previous problem and then solve this and share your answer in the comments. Okay, now we finally come to the capstone problem that I put out at the beginning of this video. Once again, what it says is numbers 1 to 29 written on a board. At every step, you are taking a pair, erasing it and replacing it with their positive difference, and this is done repeatedly till there is only one number left on the board. Can that number be 0? And the way we will do this problem is in 2 steps. First, we will look at what is the parity of the sum of all the numbers on the board to begin with. So you have the numbers from 1 to 29 written on the board. So you add all of them up, and what do you get? So you will get the sum from 1, 2, 3 all the way up to 29, and again using that formula n times n plus 1 by 2, this will be 29 times 30 by 2, and then 30 by 2 is 15, and 29 by 15 is whatever, but I know it is an odd number. So all I care about is whether the initial parity of the sum is odd or even. So the initial parity is odd. And now what we will look at is what happens to the parity of the sum of the remaining numbers on the board at every step. How does the parity of the sum change at every step? So there are three cases. The pair that you are removing has one even and one odd number, and the pair that you are removing has both odd numbers. So let's take the example where the pair you are picking up is both even numbers. So let's say you pick 10 and 4 to replace with their positive difference, which is 6. So if you do that, what will happen to the parity of the sum? So the original parity is odd, and now from that odd total sum, you are taking out 10 and 4, and the sum of 10 and 4 will be even. So you're taking out an even number, and then you're replacing it with the positive difference, which is 6. So what you're really doing in this case is you're starting off with an odd parity, and then you're replacing these two numbers whose sum is even. So you are removing some even contribution to the sum, and then you are replacing it with the positive difference, which is also even. So this is just parity. This is not really variables or constants here. So I'm just using O and E to denote odd, even, and so on. So if you are subtracting from an odd parity something with even parity, so that's odd, and then adding something with even parity, so that's odd again. So what this means is that if you replace an even pair with its positive, if you replace a pair with both evens with the positive difference, the parity is not really changing. So the parity will still be odd. The parity of the sum will still be odd. Similarly, if you take an even and odd number as the pair, so let's take 1 and 8 as the pair to replace. So 1 and 8, the sum is 9, which is odd, and then the positive difference is 7, which is also odd. So from an original odd parity, you are subtracting something that's of even parity or that's of odd parity, and then you're adding something that's of odd parity. So what should happen? So from odd, you're subtracting odd, that should give you even, and then you add odd again, so you should get odd again. So even in this case, the parity of the sum will stay odd. And then what happens if you take out a pair of odd numbers? So let's say you take out 7 and 3. So 7 and 3, the sum is 10, which is even, and the difference is 4, which is even again. So from a number of odd parity, you will subtract a number of even parity and then add back something of even parity. So odd minus even should be odd, and then you add even should be odd again. So the parity in this case of the sum will also be odd. So no matter what pair you replace, the parity of the sum will still be odd. So at every step, the parity will continue to be odd, and therefore the parity of the sum will never change. It will always stay odd. And because the question asked us, can the final number be 0? But 0 is of even parity. So there's no way the final number can be 0, because at every step, what you're getting is a sum of odd parity. And therefore, the answer to this question, can that number be 0? The answer is no. And that solves the capstone problem and brings us to the close of this masterclass. Congrats, you have actually managed to solve a very tough problem that, without this thinking around parity, not many people will be able to solve. I hope you understood it. I hope you liked it. Let me know what you think in the comments.